All right, in this video we're going to see how to name acids, and we're going to simplify. For the purpose of this video, acids are going to be typically something that has H at the front of the formula followed by something else. The technical definition of an acid is more complex, but we're just going to keep it really simple for now. So there are two major classes of acids. There are what are called binary acids. Binary acids are kind of what they sound like. They're H and one other element. So some binary acids are like HF, HBr, HI, or even H2S. And the way you figure out how many hydrogens go with a binary acid is you look at the charges. F, Br, and I all form charges of -1, so they get one H to go with them because the H is really H+. So HF, HBr, HI. S is a -2 charge, so it's H2S. And the general way you name binary acids is you say it's hydro blank ic acid, the blank being whatever the name of the other element is. So HF is hydrofluoric acid, and HBr is hydrobromic acid, and etc. I'm not going to write them all out. Hydroiodic, hydrosulfuric acid. So that's the first class. The other class are oxoacids, which, as their name implies, have oxygen in them. And so an example of an oxoacid is HNO3. We recognize NO3 as nitrate from our ion group. It's NO3 minus. And we say, okay, it's HNO3 because it takes one H to neutralize the NO3 minus. Another one is H2SO4. You might recognize SO4 2 minus as sulfate. So that's what we would look at there. And the way we name these acids is there's no hydro on the front. All you do is take the ion that it's with, the polyatomic, and change its ending. And if the ending is 8, you change it to IC. So what this means is NO3 minus is nitrate. HNO3 is simply known as nitric acid. Not hydronitric or anything like that. Just nitric acid means take the NO3 minus, add hydrogen to it. H2SO4 then is going to be, we say sulfuric acid. Sulfic acid just doesn't sound as good. So you just take the 8 ending and you change it to ic. Now this is not going to be on our class one, but there's also, just to clarify, sometimes you might have something like HNO2, which you'd recognize NO2 minus is actually nitrite. So the rule for ite, I-T-E, is you change the ending to OUS. So if you ever saw one like that, this would be considered nitrous acid. H2SO3 would be sulfurous acid. So that's not going to be on our test. We're just going to really stick to the 8 ones, but it's just good to know and be familiar with those others. So binary, hydroblankic, oxoacids, just take the polyatomic, change the ending, add acid. So those are the two major classifications. Okay, let's put this to practice. So this first one is a binary acid. We know because it only has 2 types. So it's going to be hydro. And again, bromine is the other atom, so it's hydrobromic acid. That's it. This one, HNO3, NO3 is nitrate, NO3 minus. So this is simply nitric acid because the 8 changes to ic. This, we recognize CO3 2 minus as carbonate. This is not binary, it's an oxoacid, so this is going to be carbonic acid. This is what's in soda. And lastly, H2S, this is binary because it's got H and S and nothing else. So binary is always hydro, and S is going to be sulfuric acid. And that's how we name them. Now if I want to write the names, I say phosphoric acid. So this name, this means that the acid is going to be formed with phosphate. I recognize phosphate as PO43 minus. Again, it's phosphate because it's ic. I have to know what phosphate is. And I say, how many hydrogens will it take to neutralize phosphate? 3, because each one's +1. So phosphoric acid is H3PO4. Sulfuric acid, I recognize this is oxoacid, SO4 2 minus, so sulfuric becomes sulfate. That's going to take 2 hydrogens to neutralize, so H2SO4. Hydrofluoric, I say this is binary because of the hydro. I know fluorine is F minus, so hydrofluoric will be HF. And then hydrosulfuric, we did this one on the last page. It's binary because of the hydro. Sulfur forms a -2 charge from the periodic table, so this is H2S. So that's pretty much how you go about this. Just take some practice at it until you get comfortable with it. But you really shouldn't have to memorize all the acids, because once you get the system down, it's a lot easier just to kind of figure them out from that. So until next time, I am Derek Genova. Have a delightful day.